Okay, we will be starting chapter 7. Okay, it's about triangles, and then the main topic is about proving two triangles to be concurrent. So, what do you understand by concurrent triangles? So, let's draw two triangles. Okay, if I make a copy of this and paste it here, it will be exact replica of this, right? So these two is, we can say it's concurrent. So concurrent literally means exact replica. Okay, you can turn this around, doesn't matter, but the side length, the length of the sides and the angles will not change. Okay, so this means they are concurrent. So understanding what is a concurrent triangle is quite easy. It literally means the exact replica, but then the complicated part is proving two triangles are concurrent. So in case there's two triangles, right? I said this is 7 centimeter, this is 7 centimeter, this is 6 centimeter, this is 6 centimeter. Now, and then I say this is 30 degrees and this is also 30 degrees. But we don't know about this side. We don't know about this side either. We don't know about this angle, we don't know about this angle, neither do we know about this angle. But I can say that these two triangles are exact replica of each other because two of the sides are equal and one angle in between is same. That rule is called side angle side. So one side each, one angle each, and then one more side each, side angle side. So according to side angle side, these two should be concurrent. Okay. So concurrent means these are exact replica. So even without knowing the lengths or the angles of the two triangles, I can like say that these two triangles is concurrent because this, and this are equal. Got it? So it's like if you do construction, okay, it concurrency literally means this only in what I understand. If you do construction, just knowing this tree, you could construct a triangle. That's what it literally means. If you take 7 centimeter and then do a 30 degree and then cut a 6, then your triangle is complete. So if suppose there's they're asking you like to prove something is concurrent to other and you don't know the rule, one of the rule is side angle side, the other rule is angle side angle, which means if there's two triangles and you know two angles are equal, suppose this is 43, this is 42, this is 43, this is 42, exactly the same, and then you know the side in between them, 7, then we can literally say these two is also concurrent because if you draw a 7 centimeter, then draw an angle and draw an angle, they'll intersect at one point and it will become a triangle when you're constructing. Okay, so itu tinda ikla takilibi triangle ikta punawa pare. Itu aja. So in these two also SAS, which means if the angles of this and this are equal, angles is equal, and the side in between them are equal, then we can say that they are concurrent by the rule of ASA. So ASA can be written as AS also, okay? Because what if you see, suppose this angle are same. Let's say 30, let's say 70. So we know automatic, see, it's ASA rule, right? But then I'm telling you that we can show that this is concurrent by AAS also. Why? Because if we do know that these two angles are equal, by automatic default, this will also become equal. Why? Because according to angle sum of property, this plus this is 180, this plus this is 180. So this and this will automatically become equal as well. So which literally means that it's the same thing as ASA only. Got it? So it can be SAA also, doesn't matter. I hope you got the point. So the next rule is, these two is like literally the same rule, okay? So one is SAS, one is two angles, one side, one is two sides, one angle, and then the other one is side. So if you know the sides of two triangles to be same, 6, 6, 7, 7, 5, 5, you know that these sides are same, then you can literally say that this is concurrent, and by automatic, all the angles will become equal as well. Not all three, but this will be equal to this will be equal to this will be equal to this. Okay. So we cannot, what can't we use? We cannot use A, A. You have to remember that. You cannot use A. If three angles are same, for example, in a very easy way, let me give an example. Like in case you draw an equilateral triangle. Okay, this is an equilateral and this is also an equilateral triangle. Suppose this is 2, 2, 2. Equilateral triangle is all sides are equal. This is 7, 7, 7. Obviously, this 2 is not concurrent because this is way larger than this, right? But then we do know that all equilateral triangles have the angle 60 degrees. So even if it's a big equilateral triangle or small equilateral triangle, everything will be 60 degrees. So all the angles are the same, but even though all the angles are the same, the sides are not same. So we cannot use this. This is not allowed. So we can use this stuff. Okay, to show that two triangles are concurrent. Anyway, one last thing, CPCT. CPCT literally means corresponding parts of concurrent triangle. Okay, CPCT is used when suppose they are asking a question. Example, these two. We know that this two is concurrent because this and this is equal, this and this is equal, the angle between them is equal, SAS rule. We know that those two is concurrent. So we now know that this one and this one, this line and this line, the base will also be same, right? Why would it be same? Because we know that this two is concurrent. Concurrent means exact replica. Even if we don't know the measurement, we can assume that if we measure these two, they will measure out to be the same value. So that theory, that if two triangles are concurrent, we know that the other stuff, this side will be equal to this side, this angle will be equal to this angle will be equal to this angle, is called CPCT. Okay, so if they're asking you to prove that this and this is equal, you can, once you show that these two triangles are concurrent, you can just say that this is equal to this, CPCT. Okay, that's what it means. So let's start exercise 7.1. Question number 1. In an equilateral triangle ABCD, quadrilateral, ABCD, AC equal to AD. They're saying AC and AD have the same measurement. They did not give us in numbers the measurement, but they're saying that they have the same measurement, right? AC equal to AD. And then BD bisects angle A. So what do you understand by the term bisect? Bi. In maths, bi means 2, okay? So bisect means dividing into two equal portions. Okay, so they're saying angle AB bisects angle A. So angle A is the whole thing. This entire thing is angle A, right? So angle A is this DCA. This whole thing is angle A. This angle A is being divided into two equal parts. So if the whole angle is 100, this will be 50 and this will be 50. So itu or itu same ho jao angle. Which is na bisect means that. So show that triangle this is concurrent to this triangle and this triangle. Up triangle and bottom triangle is concurrent. We have to show. So let's start. In triangle ABC and triangle ABD, we know that AC equal to AD. How do we know? Because it's given in the question. Simple. It's given in the question, right? Next, we know that angle BAC equal to angle BAD. Why is that? BAC is this and BAD is this. Like literally, I just told you that these two angles will be same. If this whole thing is 100, this will be 50, this will be 50. So these two become same. That's why I wrote this equal to this. Those two is same. Why is it same? Because AB bisects angle A, right? And then lastly, see, if I take this triangle, okay, the up triangle, I'll draw it here, CAB, and I take the lower triangle, I'll draw it here, ABD. It's supposed to be same size, but same size as about it. Anyway, these two triangles are there. We just show that this is equal to this, and then this angle is equal to this angle. Now we need an angle or a side. We need one angle or one side, because in the starting I've already told you we need three stuffs. 3 sides, 2 sides, 1 angle, 2 angles, 1 side, or yeah, 2 angles, 1 side. So We need at least an angle or a side, right? So we have already done this. So if you observe carefully, what you will notice is that in this line we have AB. In this line also we have AB. So if this is 10 centimeter, by automatic this will also be 10 centimeter because it's the same line, right? So for both triangles, they're showing AB and AB. So AB equal to AB is called common. Okay, they're showing the common base or common side. So you can say that triangle ABC is congruent to triangle ABD by what rule? Side, angle, side. A very, very important thing you have to remember is that when I'm writing triangle ABC is congruent to ABD, you cannot just simply write ABC is congruent to triangle the same thing but BAD. You cannot write like this, okay? You have to write in according to what is same. So itu confuse kayak boleh na. One thing you can easily remember is draw both the triangles but in the same direction. This is up and down, right? But draw both the triangles in the same direction. First, write the names of the triangle first. One of the triangles, anyone. Now, this one I've written down. ABC I've written down. The bottom one I still have not written. So I'm going to write the name of this in according to what is equal with this. So in first case, we show that AC is equal to AD. AC is this side, this side. So I need AD to be this side. Got it? So AD. And then we show BAC. BAC is equal to BAD. BAD. So everything is matching up now. BAB equal to AB. So AB. So AB equal to AB. Now this and this is equal, this and this is equal, and this angle and this angle is equal. Once you have written this down, now you can write any way you want in according to the order. Since I'm starting with A, B, C, this should also go A, B, D. So you cannot do this if you're writing A, B, C, A, B, C. You have to go the same pattern, A, B, D. You can even do C, B, A, C, B, A. Then you have to go the same pattern, D, B, A. This is very, very important, okay? Because your exams will be multiple choice. So multiple choice, there's these proof questions will not come, obviously. So they might ask you based on this kind of questions only. How are the two similar triangles? And they'll just flip one of these alphabets and make you confused. So always remember, you draw both the triangles and write according how it is congruent, and then the order should always be same. Got it? So that's it. So what can you say about BC and BD? BC and BD will also be equal. BC equal to BD. Right? Why will it be equal? Because we just see this. We literally wrote here that these two triangles are concurrent. Concurrent means replica of each other. So if this is replica of this, obviously this will be equal to this. What is the reason? CP, CD. That's what I was talking about. Since two triangles are concurrent, we can say that those two are also equal. Okay. Let's do number 2. Number 2, in triangle, ABCD is a quadrilateral in which AD is equal to BC. So they're saying AD and BC is same. So AD is here, BC is here, these two are same. Angle DAB, which is this angle, is equal to CBA, this angle. Okay, so I'm gonna do the proving up to question number 3 because you guys do need to know how to prove stuff, you know. After that, I'm gonna skip the proving part and then just show you shortcuts how to know which one is concurrent to what and all the stuff, okay? Because you will be doing it MCQ wise only, so we don't actually need that much. So first question is ABD. So let me just draw the diagram here. This, I'm gonna separate the diagram, okay? ABC, the same diagram, I'm just taking it out and writing it here. And then I'm gonna take this out. A, B, D. This and this is equal. So this side and this side is equal. This angle and this angle is equal. We need one more. What will it be? We have already done it in the previous one. If you look closely, you can see AB here AB here. So AB is being shared between the two triangles, so AB will be equal to AB. So now I'm gonna flip this around and then write it here with the same direction as this, so that we will not get confused while naming it. So angle B is equal to angle A, so A should be here, right? And then AB is equal to AB, so B should be here because AB should be together. And then DA and BC is equal, so this and this is equal, so this is the bottom, this is also the bottom. So that's how you rearrange stuff, and then you start naming it. So in triangle ABC and triangle BAD. See, now I can say ABC and BAD, doesn't matter. Okay, or you could even say ABD and BAC, same thing. So we can say that AB equal to BA, AB equal to BA, why? Common. BC equal to AD, or let's write the angle first. Angle ABC equal to angle BAD. It's given in the question, right? And then BC equal to AD. That's also given in the question. Therefore, triangle ABC is congruent to triangle BAD by what rule? Side angle side. Now, they're asking us to show that BD equal to AC. Obviously, BD is this one, AC is this one, and we just literally showed that this two is concurrent, so it will be same. So BD equal to AC by what reason? Simplicity. And then they're also asking us to show that angle B, ABD. ABD. This angle is equal to BAC, this angle. Same reason. We just showed that those two are concurrent, which means every part of the first triangle will be equal to every part of the second triangle. CPCD. Got it? Let's try number 3. So number 3, let's read the question first. AD and BC, where is AD? AD is here, BC is here, are equal perpendiculars. What do you understand by the term perpendiculars? Perpendiculars literally means 90 degrees. Don't forget it, okay? So this is 90 degree and this is 90 degree. Perpendiculars to a line segment AB. So AB is a line segment, this is the perpendicular, this is the perpendicular. Show that CD bisects AB. We have to show that CD bisects AB. And bisects means what? It divides into two equal portions, right? So we have to show that AB is CD is cutting AB into two equal portions. So we have to show that AO equal to BO. So let's try to prove that these two triangles are concurrent first. Okay. 90-90 means next. Second thing you have to notice is this. In the question it says equal, which means this AD and BC is equal. This AO and BO is not equal. Okay, we have to show that it's equal. Okay, so last class I've already told you in chapter 6 that if two lines intersect, this angle will always be equal to this angle. Why? Because these are opposite angles, vertically opposite angles. So we know that this and this will be equals, vertically opposite. 90-90 is there, and then side is there, so we can show that these two triangles are concurrent. So before we do that, let's draw the diagram of one of the triangles, and then let's draw the diagram of this triangle but in the same direction as how we drew it here. So let's name BCO. Vertically opposite angle O and O should be equal, so O should also be here. O and O is equal, and then BC is equal to AD. So BC is equal to AD. So this and this is equal, 90 degree, angle O is same. So we have everything here. We have everything that we need here. So in triangle ADO, so since I'm taking this direction, BCO and triangle BCO, right? Angle O or BOC, angle BOC is equal to angle AOD, vertical opposite angles. It doesn't matter which angle you first write. Okay, next, this angle, which is angle OAD equal to angle OBC, OAD, 90 degree each. Everything is 90 degree, and then we can write AD equal to BC. AD is equal to BC. Why? Because they are given in the question. Therefore, triangle ADO is concurrent to triangle BCO by what rule? Angle side. Okay, so if these two triangles are concurrent, can we say that AO and BO are same? Therefore, AO equal to BO, CPCT. And we needed to prove that AO equal to BO. So we can say, hence, AB, CD bisects AB. Because CD is this, so it's cutting AB into two equal parts. Even these two, we can show that it's equal to OD, so we can say that they bisect each other also. Okay, so that's how it's done.